Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to Math Solver 1117. Do you struggle with short question in maths? Don't worry, in this video I will solve Model Paper 2025 by Federal Board short question in easy and simple way. If you are new, subscribe Math Solver 1117 and also hit the bell icon to get notification for all upcoming videos. Now we will start from question number 1. Now the question number 1 is, if z is equal to x plus iota y, then simplify the equation z minus 2 iota is equal to the z bar plus 3. Now we will solve this question. First of all, the first step is z is equal to x plus iota y and z bar represent the complex conjugate of this, which is equal to the x minus iota y. This means that in the conjugate the real part of z is same as x, but the imaginary part has the opposite sign. That's why z bar is equal to x minus iota y. Now we will put the values in this given equation, that z is equal to x plus iota y minus 2 iota and z bar which is equal to the x minus iota y plus 3. Now we will join the real part and imaginary part, then x plus iota into y minus 2, and in this part we have x plus 3 minus iota y. Now in the next step we will find the magnitude of this, which will be equal to the, so as we know that the magnitude of z bar will be equal to the square root of x square plus y square when z is equal to the x plus iota y. So we will apply this here, that square root x square plus y minus 2 square, and this is equal to the x plus 3 square plus y square. Now taking the square on both sides, we will have x square plus y minus 2 square whole square and x plus 3 square plus y square whole square. Now this square is cancelled by this square root and this square is cancelled by this square root. We have x square plus y minus 2 square, and this is equal to the x plus 3 square plus y square. Now we will solve this. Now we will open the square of this. Here we apply the formula of a minus b whole square, which is equal to a square minus 2ab plus b square, and a plus b whole square, which is equal to a square plus 2ab plus b square. Now by using this we will get x square plus y minus 2 whole square means y square minus 2 into y into 2 plus 2 square, and here we apply the formula. It will become x square plus 2 into 3 into x plus 3 square plus y square. So this will become x square plus y square minus 4y plus 4, and this is equal to the x square plus 6x plus 9 plus y square. Now we have x square plus y square minus 4y plus 4 minus x square minus 6x minus 9 minus y square is equal to 0. x square is cancelled by this x square, y square is cancelled by this, and we have minus 4y minus 6x, 9 minus 4 is minus 5 is equal to 0. Now, by taking the minus as common, remaining is 4y plus 6x plus 5 is equal to 0. Then this will become 4y plus 6x plus 5 is equal to 0. Now we will write 6x plus 4y is equal to 5. This is the answer of this question. Now we will solve question number 2. Now question number 2 is prove that cos pi by 3 plus x minus sin pi by 6 minus x is equal to the 0. Now in this question we will take the left hand side and prove that left hand side is equal to the right hand side. Left hand side is cos pi by 3 plus x minus sin pi by 6 minus x. Here we apply two formulas. First is cos alpha plus beta, which is equal to cos of alpha and cos of beta minus sin of alpha, sin of beta. And in this case we apply the formula of sin of alpha minus beta, which is equal to sin alpha cos beta and minus sin beta cos alpha. So we will apply these two formulas in this. We have cos pi by 3 and cos x minus sin pi by 3 sin x. Here we have the value is minus sin pi by 6 and cos x and minus sin x and cos pi by 6. Now we know that cos pi by 3 is equal to 1 by 2 into cos of x minus sin pi by 3 is equal to square root of 3 by 2 sin of x minus sin pi by 6 is equal to minus 1 by 2 cos of x, and then minus minus plus and sin x and cos pi by 6 is equal to the square root of 3 minus 2 into sin of x. Now all the terms can be cancelled out, 1 by 2 cos x and minus 1 by 2 minus 3 by 2 sin x and plus 3 by 2. So this is equal to the 0 and which is equal to the right hand side. Hence we prove that left hand side is equal to the right hand side. Now we will solve question number 3. Now the question number 3 is find volume of a tetrahedron. A is equal to 2i minus 3j plus k, b is equal to I plus 2j minus k, and c is equal to 3i minus j plus 5k. Now we will apply first the formula of this to find the volume. So the formula of volume is equal to the 1 by 6 into A dot B cross C. Now we will find the value of this A dot B cross C, where three vectors are given A, B and C. We can easily find the value of this. This will be equal to A dot B cross C is equal to the, we will write the constants of A in the first row, 2, minus 3 and 1, and then 1, 2 and minus 1 and 3, minus 1 and 5. We will expand this with respect to R1. So we will get 2 into, we will multiply 2 into 5, 10, 1 into 1, 1 minus minus plus and then minus, and minus 3 will become plus 3, and 1 into 5 is 5, and 3 into minus 1 is plus 1. Then plus 1, 1 into minus 1 is minus 1, 2 into 3 is 6 and then minus 6. So this will become 2 into 1 minus 10 minus 1 is 9, plus 3 into 5 plus 1 is 6, plus 1 into minus 7. So 2 into 9 is 18, plus 3 into 6 is, now here we have 3 into 1 into 5 is 5 and 3 minus 1, this is 3. So 3 into 8 will be 24 and minus 7. Now 18 plus 24 will be 42. 42 minus 7 is 35. We have the value of A dot B cross C is equal to 35. So put this value in this equation. So volume will be equal to 1 by 6 into 35 means 35 by 6. So this is the final answer. Now we will solve question number 4. Now the question number 3 is find volume of a tetrahedron if A vector is given 2i minus 3j plus k and B vector is I plus 2j minus k and C is minus 3i minus j plus 5k. These are the values given and you have to find the volume. Volume is equal to 1 by 6 into A dot B cross C. So you will first find A dot B cross C, which is equal to the A dot B cross C will be equal to the 2 minus 3 1, all the values of this, and then 1 2 and minus 1 minus 3 minus 1 and 5. Now expand this with respect to R1. So 2 into 5 is 10, or you can write first as 2 minus 1 and 5. Then write minus 3 will become plus 3, 1 minus 3 and minus 1 and 5. Now the third one is plus 1 and 1, 2 minus 3 and minus 1. Now this will equal to the 2 into 5 into 2 is 10, minus minus plus, then minus 1, plus 3, 5, and 3 into 1 is 1, minus minus plus, then minus 1, minus 3, then plus 1 and minus 1, 3 into 2 is 6 plus 1, so this will become plus 6. Now 10 minus 1 is 9, 9 into 2 is 18, 5 into 3, 5 minus 3 is 2, 2 into 3 is 6, and then 6 minus 1 is 5, so plus 5. So you have 18 plus 6 is 24 and 24 plus 5 is 29. Now we will use this value in this formula. A dot B cross C is equal to the 29. So 1 by 6 into 29 is 29 by 6. So this is the final answer of this question. Now we will solve question number 4. Now in question number 4 we have function h of x is equal to 7x4 minus 10x cube plus 3x square plus 3x minus 3, and only one zero of h of x is 1. Then find remaining zeros. Now we will solve this question by synthetic division. According to that, it is given. Now we can solve this question by both division method or by synthetic division. First we solve this by synthetic division. It is given that 1 is the factor. So first of all write the constant 7 minus 10, 3, 3 and minus 3. And 1 is the factor. So we can write 1 into 7 is 7. So 7 into 1 is 7. Now solve this. Minus 10 plus 7 is minus 3. Now multiply minus 3 into 1 is minus 3. 3 into minus 3 will become 0. Now 0 into 1 will be 0. And then 3 plus 0 is 3. Then 3 into 1 will be 3. So 3 minus 3 is 0. So we will write this equation as 7. This x power 0, x power 1, x power 2 and x power 3. Minus 3 x power 2 plus 0 plus 3. So this is the answer. Now we can also solve this by division method. So by division method, first of all we will write 7x4 minus 10x cube plus 3x square plus 3x minus 3. Now divide this by x minus 1. So 7x4 will become by x, multiply this by 7x square, 7x cube. So 7x cube multiply x is 7x 4, then minus 7x cube. Now circle the old sign and get the new sign. 7x4 minus 7x4 are cancel out. Minus 10x cube and plus 7x cube is minus 3x cube plus 3x square. Now to make minus 3x cube, we will multiply x by minus 3 of x square. So this is equal to minus 3x cube. Minus 3x square into minus 1 will become plus 3x square. Now all the terms are cancel out. 3x cube plus 3x cube, 3x square minus 3x square. So we have 3 of x minus 3. So we will multiply x by 3. This will become 3 of x minus 3. Now change the old sign and get the new sign. All the terms are cancelled out and we have just 7x cube minus 3x square plus 3 is the answer of this. Now we will solve question number 5. Now question number 6 is, without drawing graph, find amplitude, period and frequency of the function y is equal to 3 into sine 5x plus 2. So we will find this value by the formulas. Now when we have the function such that y is equal to the a sine of bx plus c. So we have to find first of all amplitude. So the formula of this is equal to the magnitude of a. Magnitude of a means mod of 3. So this will equal to the 3. Now we will find the period. So formula of period is 2 pi by b. So we have 2 pi and the value of b is 5. So period will be equal to the 5. Now we have the frequency. So we know that frequency is equal to 1 by period. So 1 by period means 1 by 2 pi by 5. So this will be equal to 5 by 2 pi. So this is the answer. Now we will solve question number 7. Now question number 7 is, in arithmetic progression, sum of first 10 term is 200 and sum up to the 20 terms is 1000. Find the common difference at the first term. Now we will solve this question. You have to find the value of d and you have to find the first term a. So you have the value of S10 is equal to the 200 and S20 is equal to the 1000. Now these values are given, and the general formula of Sn you know that is n by 2 into 2a plus n minus 1 into d. So in this formula you have to find the value of a and d. So first you put this for S10, which is equal to 200. So you will write S10 means n is equal to 10. So 10 by 2 into 2a plus 10 minus 1 is 9. 9 into d. So the value of S10 is equal to the 200, and 2 divided by 10 is 5. 5 into 2a plus 9d. So this 5 is divided by 200. We will get 40 is equal to the 2a plus 9d. This is the equation 1. Now we will solve S20. It's mean that n is equal to 20. So 20 by 2, apply this value in this formula. 2a plus 20 minus 1 is 19 into d. Now the value of S20 is given 1000, and 2 is divided by 20 will equal to 10. 2a plus 19d. So this 10 is divided by this, we have 100, which is equal to 2a plus 19d. This is the equation 2. Now we will solve 1 and 2 by substitution or by elimination method to find the value of a and d. Now we will solve these two equations. Subtract 1 and 2, circle the old sign and get the new sign. 100 minus 40 is equal to the 60, and 2a minus 2a are cancelled out. 19 minus 9 is 10d. So value of d is equal to the 60 by 10, and this is equal to the 6. Now we have d is equal to 6. We will put the value of d in any one equation. So 100 is equal to 2a plus 19 into 6. So 19 into 6 is equal to the, so we have 2a plus 114 and 100, and 2a will be equal to the 100 minus 114, and this is equal to the minus 14. Then a will be equal to minus 7. So this is the final answer. Now we will solve question number. Now the question number 8 is, without expansion show that this determinant is equal to the 0. So here we apply some formulas. First of all, arrange this as in the diagonal you have 0. So you will interchange R1 and R2. So R1 and R2. So this will become as 0 y minus x and x minus z 0 minus y 0 z. In the next step, you will interchange R2 and R3. So 0 y minus x minus y 0 and z, and in the next you have x minus z and 0. Now you have 0 in the diagonal, so you apply here operation is R2 R3 interchange. You will also write interchange Now in the next step, you will solve these as, now multiply, first column is by z. So you will write as multiply C1 by Z and C2 by X, C2 by X and C3 by Y. Now you will get 1 by XYZ and this will equal to 0 minus YZ XZ Y X 0 and minus Z X, and here you will have minus X Y Z Y and 0. Now in the next step you will make any two rows or any two columns identical. For this purpose you will add C1 and C2. So 1 over XYZ, when you add 0 plus Y of X, so it will become, or you can add or subtract. So if you add, so 0 plus Y of X is Y of X minus YZ and XZ minus XZ is 0. And the remaining terms are Y of X, 0 minus Z of X and minus X of Y, ZY and 0. Now from this, if you take minus as common from C1, here you have C1 minus C2 or C1 plus C2 have applied, and in the next step you will take minus 1 as common from the C1. So YX YZ plus YZ and minus Y of X and 0, and Y of X 0 minus Z of X minus XY ZY and 0. If you see, you can C1 and C3 are identical. C1 is equal to C3, both are identical. This is minus YX minus XY YZ ZY 0 and 0. C1 and C3 is identical, so the determinant of this equal to 0 and this is equal to the right hand side. Now we will solve question number 9. Now the question number 8 is, a carpenter made a set of 50 wooden structure of Minare, Pakistan in different sizes. The height of largest was 70 meter, R is 0.95 and you have to find A50 and S50. So the formula for this will be, and this is a geometric sequence, so AN is equal to the AR n minus 1. This is the formula for geometric sequence AN, and you have to find the value of A50. So A50 is equal to the value of A is given 70, because this is the largest. So 70 and R is 0.95 and N is 50, so 50 minus 1. So 70 into 0.95, 49. So by solving this with the help of calculator, we will get the value of this is equal to the 70 multiplied by 0.95 raised to power 49 is equal to 5.39 centimeter. Now we will find the value of S50. So the formula of this is given, Sn is equal to the A into 1 minus R raised to power n by 1 minus R. So the value of A is 70 and 1 minus Rn. Rn is 0.95 95 raised to power 50 divided by 1 minus r means 1 minus 0.95. So by solving this with the help of calculator, we will get the value of S50 such that 70 multiplied by 1 minus 0.95 raised to power 50. So this is equal to 64.613. So divide this by 1 minus 0.95 is equal to the 0.05. So our answer is equal to 1292.277. So this is the answer. Now question number 9 is find the last two digits of 23 raised to power 14. So 23 raised to power 14 can be write as 23 square into 7, and 23 square is 529 raised to power 7. So 529 can be write as 530 minus 1 raised to power 7. Now we will write this by binomial expansion. According to that, 7c0 530 raised to power 7 minus 7c1 530 raised to power 6, and then up to so on we will get 7c6 530 raised to power 1 and then minus 1. So by solving this we will get, we just have the find the value of last two digits. So we will multiply 7c6 multiply by 530, and this expression can be write as multiply by some constant, or consider this as k plus. So 530 multiply 7 will be equal to the 3710 minus 1, which is equal to 3709. So last two digits will be 09, and this is the answer. Now the question number 10 is, if z is equal to x plus iota y and arg of z minus 1 by z plus 1 is equal to pi by 2, then show that x square plus y square is equal to 1. We will solve this question. First of all, given that arg of z minus 1 by z plus 1 is equal to pi by 2. We will apply the value on this z minus 1 by z plus 1. Z is x plus iota y minus 1, then x plus iota y plus 1. So this will become x minus 1 into plus iota y and x plus 1 into plus iota y. Now we will rationalize this as multiply by x plus 1 minus iota y and x plus 1 minus iota y. So we will have x multiply by this, we will get x into x is x square, then x into 1 is plus x, then minus iota xy, and then we have minus 1 multiply this is minus x minus 1 plus iota y, and then multiply iota y by this, we will have plus iota xy, then plus iota y, then plus minus minus, iota square is also minus 1, so plus y square. Now in the denominator we have x plus 1 into x plus 1 is x plus 1 square, then plus minus minus, iota square is minus 1, so plus y square. In the denominator we have this. Now we will solve. Plus x is cancelled by minus x and iota xy is cancelled by plus iota xy, and we have real parts are x square minus 1 and plus y square and plus 2 iota y by x plus 1 square plus y square. Now we will solve this further by separating the real and imaginary parts. So the real part of this is by taking the tan inverse of 2y by x square minus 1 plus y square, and denominator of this is also x plus 1 square by y square, and also of this is x plus 1 square plus y square. So these terms are cancelled out and we have just tan inverse 2y by x square minus 1 plus x square. Now we have the value of this is pi by 2. So pi by 2 will be equal to the, we will write pi by 2, tan inverse will become tan pi by 2 is equal to 2y by x square minus 1 plus y square. So this is equal to 1 by 0, tan pi by 2 is equal to 1 by 0. So 2y by x square minus 1 plus y square, cross multiply this will give you x square plus y square minus 1 is equal to 0, and then x square plus y square is equal to 1. So this is the final answer of this question. Now we will solve question number 11. Now question number 11 is use binomial theorem to find the remainder when 599 is divided by 13. We will solve this question as, first of all, you will write 599 as equal to 598.5, and then 598 can be write as 5 square, power is 49 multiply by 5. So this is equal to 5 into, now this is 25 raised to power 49.5. So this can be write as 25 can be write as 26 minus 1 raised to power 49, or we can write this as minus 1 plus 26 raised to power 49. So we will solve this as, expand this by binomial, we will have 5 and then 49 C0 minus 1 raised to power 49, then plus 48 C1 minus 1 raised to power 48 and up to so on. So, and then in last we have plus 26. So this will be equal to the, now we will write this as 5 into, this will become minus 1. So minus 1 and then plus 5 into 26. We have to divide this by 13. So we will write this as 5 into 26 and then minus 5. To make this 13, to make minus 5 13, we will subtract minus 8 and plus 8. So this will become equal to the, so this all is divided by 13, and the now remainder we will get is 5 into 26 minus 13 plus 8. These two terms can be divided by 13, so remainder is 8. Now we will solve the last question, question number 12. Now question number 12 is, if a is equal to x, y, 0, 1, then show that a raised to power n is equal to x raised to power n, y, x raised to power n minus 1, 0, 1, and n belongs to z positive. We will prove this first of all for n is equal to 1. This will become a raised to power 1 is equal to x raised to power 1, y, x raised to power 1 minus 1 is 0, 0 and 1. This is equal to x, y, 0 and 1. Now we will prove this for n is equal to k plus 1 or n plus 1. So a raised to power n plus 1 will be equal to a raised to power n multiply a. So a raised to power n can be write as xn y x raised to power n minus 1 and then 0, 1, x, y, 0 and 1. Now we will multiply both these. Will give you x raised to power n plus 1 and 0, then y multiply this is y into x raised to power n minus 1 plus 1, and here you will have multiply this by 1 multiply y is plus y. So xn multiply 0 is 0 and 1 multiply this is 1. So by solving this further, you will get x raised to power n plus 1 and y x raised to power n minus 1 0, 1 so it is true for n is equal to n plus 1. In the next video, we will solve the or option questions, short questions that are given in the model paper. Stay tuned. Allah Hafiz.